Well, in today's lesson, lesson 2.9, problem solving, we are going to be covering multi-step multiplication problems. And our essential question is, what can you use to draw a diagram strategy to solve a multi-step multiplication problem? All right, so we can do this. So unlock the problem. At the Sea Park, one section in the stadium has 9 rows with 18 seats in each row. In the center of each of the first 6 rows, 8 seats are in the splash zone. First 6 rows, 8 seats are in the splash zone. How many seats are not in the splash zone? And they want us to use the graphic organizer, the diagram, to help us solve this problem. So what do I need to know to find the number of seats that I need to find the number of seats that are in the splash zone, are not? How many are not in the splash zone? Okay, there are 9 rows with blank seats in each row of the section. There are 9 rows with 18 seats in each row of the section. There are 6 rows with 8 seats in each of the rows of the splash zone. Okay. Now, how will I use the information? I can multiply, because remember, each row has this number of seats. So if each row has those, we can multiply to find the number of seats in the section and the number of seats in the splash zone. And here's the diagram of it. So they said that we had 9 rows and that there was 18 seats in each row. All right, so if we didn't have anything to do with the splash zone, it would just be 9 by 18. Okay, but the first 6 rows have 8 seats in the middle. Okay, so there's 5 empty here, 5 empty here, and there's 2, 4, 6, 8 rows of 6 rows of 8 in the middle here. Okay, so if I didn't have the splash zone, my number would be 9 times 18. Well, and we know that 9 times 18, we can do a couple ways. We can go 9 times 20, take away 9 times 2. 9 times 20 is 180, take away 18 would be 162. And then 8 times 6 is just a math fact. The other way we could have done this problem is 9 times 10 is 90, plus 9 times 8 is 72, 162. All right. So we found the number of seats total, and we found the number of seats in the splash zone. What else do we need to do to solve the problem? Well, we need to subtract seats in the splash zone from the total number of seats. We need to go 162, take away 48. 6 take away, 2 take away 8 you can't do, so we'll change that to 12 and regroup from the 6 tens as 5 tens. 12 take away 8 is 4, 5 take away 1 is 1, and 1 take away nothing is 100. So we have a 114 seats not in the splash zone. right, so let's go to page 82, and they want us to try another one. And this time, at the Sea Park, one section of the Shark Theater has 8 rows with 14 seats in each row. In the middle of the section, 4 rows of 6 seats are reserved. 4 rows of 6 seats are reserved. How many seats are not reserved? What do I need to find? I need to find the question. So, how many seats are not reserved? What information do I need to use? There are 8 rows, 14 seats, and in the middle, there are 4 rows of 6 seats reserved. How will I use the information? Well, again, we have 8 rows, and in every row there are 14 seats. I can multiply. In the middle, there are 4 rows with 6 seats reserved, so I can multiply that too. So I will multiply to find the number of reserved and total seats. Okay, so solve the problem. Well, I'm going to use some graph paper, okay, rather than drawing out a bunch of squares here. So I'm just going to use some graph paper. And so my first one was 8 rows of 14. So 1, 2, 3, 4, 5, 6, 7, 8. And 14 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so that's the total number of seats. We have 8 rows, 14 seats in each row. And then it said in the middle, there are 4 rows of 6, right? Okay, so go to 4 rows of 6 in the middle. So we have 14 seats. 1, 2, 3, 4, 5, 6. Put there. And we have 4 rows. 6. So we have 4 rows. This little space here will be represented as 4 rows. Okay. I don't mean the whole thing. Just this little piece in here is 4 rows. Okay. And then inside there are 6 seats. 6 seats. So we have 4 rows of 6 seats. We have a total of 8 rows of 14 seats. So now what will we do? Well, we can go 14 times 8. I'm going to write total seats on the top. Okay, so I know that the top number is total seats. That my picture says 14 by 8. Okay. And reserved, I know is 4 rows of 6. So now we can solve this. 8 times 10 is 80. 8 times 4 is 32. So there's a total of 112 seats. 24 of those 112 are reserved. So now we're going to go 112, take away 24. 2 take away 4 we can't do, so we'll rename the 110 as 0 tens and 10 ones. 12 take away 4 is 8. 0 take away 2 we can't do, so we'll rename the 100 as 0 hundreds and 10 tens. 10 take away 2 is 8. So there's 88 seats that are not reserved. Okay. 88 seats not reserved. Okay, so what we did, we went 8 times 14, and we subtracted 6 times 4. And so how did the diagram help? Well, the diagram just helps me see a picture of what they're talking about. Okay, so this little middle section here, it wasn't open to the public in a sense. Somebody else had already chosen those seats. They were given those seats. So helps visualize or picture the problem. We're on page 83, number 1. Okay. So the seats in section A and B of the stadium are all taken for the last show. Section A has 8 rows of 14 seats each. Section B has 6 rows of 16 seats each. How many people are seated in sections A and B for the last show? So first we're going to draw and label the diagram, and then we're going to find the total number of seats in each section. Okay, so it doesn't really matter where you choose this, but I'm going to make this first part up here, section 8, and I'm going to count down 8 rows. So 1, 2, 3, 4, 5, 6, 7, 8. And there's 14 seats in each row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I know there's 8 back down this way and 14 across the front. So I can say that there are 8 rows of 14 seats in section A. So I'll call that section A. And in section B, we have 6 rows. So 1, 2, 3, 4, 5, 6 rows. And in each row, we have 16 seats. Well, we know that that was 14, so we just need to go 2 more. So that's my section B. And here we have 6 rows of 16 seats. All right. So first, draw and label a diagram. And next, find the number of seats in each section. So I know that I have to figure out how many squares basically are in my diagram. Those all represent seats. But I really don't want to take the whole time to count every single square. Right? Who wants to do that? Who wants to count 14 8 times? Or count 8 14 times? I don't want to do that. So I'm going to use multiplication. 14 times 8. And in B, I'm going to do 16 times 6. All right, so 8 times 10 is 80. 8 times 4 is 32. So section A has 112 seats. Section B, 6 times 10, 60. 6 times 6, 36 ones. So section B has 96 seats. Last, find the total number of seats. Okay, so it didn't ask me just to find section A or section B. It said how many people are seated in sections A and B. Okay, so we're going to need to add these together. 112 plus 96. You rewrite that. So they're lined up place value. 6 and 2 is 8 ones. 9 and 110 is 10 tens. We'll rename that as 100 at 0 tens. 100 plus 100, 2. So there should be 208 people seated in sections A and B at the theater. At the stadium, actually, it says, right? At the stadium. All right. Number 2. Well, what if sections A and B each had 7 rows? How many people would have been seated in sections A and B? So they're saying if we were to add an additional row for here, so plus 1 row here for section A, and if we were going to take away a row from here, so we can take away this first row, how would that change our problem? Right, so what did we do? So we're adding a row to section B, because it only had 6 rows, so we'd be adding a row of 16. But in section A, we would be taking away 1 row of 14. So how many seats am I actually gaining? I'm gaining 2 more seats. So 208 plus 2 is 210. Okay, so that's one way you can solve that problem. Let's say that I decided, well, okay, so they told me 7 rows. 14 times 7 plus 16 times 7. You can solve it that way. Okay, you can solve that way. 7 times 10 is 70. 7 times 4 ones is 28 ones. So we'd have 98 seats in section A. And in section B, we'd have 7 times 10, 70. 7 times 6 ones is 42 ones, or 112. We would then add 112 plus 98, and we'd come up with 210. So either way. So all I did was I saw that that first row was going to be taken away, and so it would have lost 14 seats. But in the section B, we're going to add a row of 16. So if I take away 16, if I take away 14, but I put in 16, I'm actually gaining 2 extra seats. So 208 plus 2. Seems to be the easiest way to do that one. All right, number 3. So Brenda's vegetable garden has 13 rows with 8 plants in each row. 13 rows, 8 plants in each row. She plans to plant, let's try to say that one fast 3 times, in the first 2 rows and the last 2 rows. The rest of the rows will be tomatoes. How many tomato plants will Brenda plant? Okay, so let's look at our, we can draw a diagram of this, right? 13 rows of 8. All right, so I know that this is 10, 11, 12, 13. Okay. So 13 rows. And in each row, we're going to have 8 plants. 1, 2, 3, 4, 5, 6, 7, 8. So she has 13 rows of 8 plants. All right. But the first 2 rows and the last 2 rows are going to be peppers. So the first 2 rows and the last 2 rows are going to be peppers. Everything in between is going to be tomato plants. So tomato plants are going to be 9 rows of 8. 9 rows of 8 for the for the tomatoes. 9 rows of 8. So what do we do now with that information? So how many tomato plants will Brenda plant? Well, do I really need to figure out how many peppers she's going to plant? I don't think so. The peppers aren't tomato plants, and I know that the first 2 rows are peppers, so why even worry about those? So if I take away the 4 rows of pepper plants, there's 13, 13 take away 4 is 9 rows left, right? So we know there's going to be 9 rows of 8 plants. Okay, so 9 times 8, 72. She's going to plant 72 tomato plants. I don't know why I put tomatoes. Let me try that again. 72 tomato plants. What I intended to say. All right, number 4. There are 8 rows of 22 chairs set up for an award ceremony at the school. In each row, the 2 chairs on each end, are reserved for students receiving awards. The rest of the chairs are for guests. How many chairs are there for guests? Okay, so let's try drawing a picture again. We have 8 rows of 22. So that's 8 rows. And we're going to go 22. So this is 10, 20, 21, 22. Okay, I knew that that's 22 rather than go 1, 2, 3, 4, because in each section there's 10 rows. Okay, so 22 and down 8. All right, so what do we have here? What's our picture showing us? Well, it's showing us that we have 8 rows, and in each row we have 22 chairs. But now, if we look at the problem, it tells us in each row, the 2 chairs on the end are reserved. Each row, the 2 chairs on the end are reserved. So I'm taking that to mean this row, okay, that first row, the end chairs will be taken up with people receiving awards. And on the other end, that will be taken up with people receiving awards. So if I'm interpreting that correctly, it's saying 2 chairs on each end. The 2 chairs on each end. So have I done 2 chairs on each end? No, I've only done 1 chair on each end. Okay, so now I have to have a second set. Now I have 2 rows, or 2 chairs, 8 rows of 2 chairs, and 8 rows of 2 chairs. So I'm going to call that 2 and 2, right? So how many chairs are for guests? That was our question. The rest of the chairs are for guests. So you can't sit here. A guest can't sit in these 16 seats, 8 times 2, 16 seats, and these 16. Okay, so if you're taking away 2 chairs from each end, you're taking away 4 chairs total in each row, right? 2 here, 2 here, you're taking away 4 chairs. There was 22 total. So in between here has to be 18 chairs. So we have 8 rows of 18 chairs for guests. So we can solve that. We can go 18 chairs at 8 chairs, 8 rows of 18. So this is one way we can do it. Okay. I just didn't count the end parts. I just basically eliminated them. Okay. Because it didn't ask me really to use the students who were sitting on the ends. It just wanted to know how many guests could sit. So if we eliminate the 2 chairs on each end, that left us with 18 chairs that people could sit in each row. So 18 times 8. 8 times 10 is 80. 8 tens is 80. And 8 ones times 8 is 64. So we add that up, we get 144 chairs for guests. Is there a different way I could have solved that problem? Yeah, there could. I could say, okay, well, there's 8 times 22. That's total. And then I know that there's 4 chairs not used in every row. So I could have said 8 times 4 is 32. And then I could have said 8 times 20 is 160. And 8 times 2 is 16. So 176 total chairs. And 32 are being taken up by students. So then we can subtract that. And 6 take away 2 is 4. 7 take away 3 is 4. And we get 1. So 2 options. Either way, I get to the right answer. This one, I just didn't even count the 2 on the ends. And I just counted how many chairs I had left in each row. Here, I counted how many total seats I had and then subtracted the number of seats that students would be sitting in. All right, let's go on page 84. All right, so let's continue with number 5. Okay, so it says use the graph for numbers 5 and 6. So we have Sea Park field trips, Miss Bird, Mr. Torres, and Mrs. Allen. And these are the number of students in each of those teachers' classrooms. So Mr. Torres took his students to the Dolphins show. Each row had 11 seats. One adult sat at each end of a row, and each group of 4 students was seated between 2 adults. And Mr. Torres sat by himself. So how many adults are there? All right. So I'm actually going to use just a blank paper on this one and draw out the diagram for this one. So I'm going to put A for the adult. And then I know that there are 4 students. I'm going to use P stand for pupil. So 4, and then another adult. So there's 4 students between 2 adults. Okay, okay, we do that. And so then there's 1, 2, 3, 4, 5, 6 so far. 7, 8, 9, 10, and then there has to be an adult at the end of the row. So there's an adult at the end of each row. There's 2 adults for every 4 students. Mr. Torres has 24 students. So right now I have 8 students. So let's see, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, And the adults will be the same on each side. And then Mr. Torres was by himself, right? I'm going to put an extra A for Mr. Torres. So I have 3 adults, 4 adults, 3 adults. So 3 and 3 is 6, plus 4 more is 10. 10 adults. Okay? 10 adults on this trip for Mr. Torres' class. All right, number 6. Another stadium section has 24 rows of 10 seats each. Describe at least 2 ways Mrs. Allen's class can sit if an equal number of students sit in each row. So Mrs. Allen's class has 36 students. And there's 24 rows of 10 seats each. If an equal number of students sit in each row. Okay, so how many so the most I can fit in any row is 10, right? Okay, so if I do, I'm just using a little guess here. If I said, okay, they're going to fill in with 10 students in each row. Well, okay, so that's 10, 10, 10, and another 10. That would be 40. She doesn't have 40 students, she's got 36. So I can't say there's 10 in each row, okay? Because it says an equal number of students sit in each row. So that won't work. How about 9? Let's try 9. 9 is 18, 27, 36. That would work, right? 4 rows of 9, okay? 4 rows of 9. It can all sit that way. Well, can I also just use the commutative property? If 4 rows of 9 work, and there's 24 rows, couldn't I do 9 rows of 4? The same numbers, same factors. So I can do that. Is there any other possibilities? Does 8 work? I don't know. Let's see. 8, 16, 24, 32, 40. No, 8 didn't work. So far only the 9 worked. Let's try 7. 7, 14, 21, 28, 35, 42. No, 7 doesn't work. How about 6? 6, 12, 18, 24, 30, 36. Okay, 6 works. I could have 6 rows of 6. So I've already described at least 2 ways. So we're good. So all I did was I'm just skip counting by the possibilities. The most I can have in a row is 10. The least I can have is 1. Could I have 1 row of 36? I mean, could I have 36 rows of 1? No, because there's only 24 rows. And I can't have 1 row of 36 because there's only 10 seats in a row. All right. So 1 wouldn't work. 2. Would 2 work? 2 does get to 36. It would be 18. So I could have 18 rows of 2. It would work. I can't have 2 rows of 18, but I could have 18 rows of 2. 3 would also work. It would take me 12 threes to get to 36. So I could have 12 rows of 3. And then 4 would be the next one we've already used 4. So those are all the possibilities. All right, number 7. So Carol, Ann, and Liz each bought a toy fish. Carol's fish is 10 inches longer than Ann's fish. Liz's fish is 2 inches longer than twice the length of Ann's fish. Ann's fish is 12 inches long. Find the length of each toy fish. Okay, well, let's see what we do know here. We know Ann equals 12 inches. We know that Liz is 2 times Ann's plus 2. 2 inches more than twice Ann's fish. Carol's fish is 10 inches longer than Ann's fish. So Carol's will be 12 plus 10. Okay, so Carol, Ann, and Liz each bought a fish. Carol's fish is 10 inches longer than Ann's. 10 inches longer than Ann's. The question told us that Ann was 12 inches long. Then Liz's is 2 inches longer than twice the length of Ann's fish. Twice the length of Ann's fish plus 2. All right, so Ann, 12 inches. Carol, 22 inches. Liz, 2 times 12 is 24, plus 2 more is 26. Okay, number 8. Nell made a secret code. Each code word has 2 letters. Each word begins with a consonant and ends with a vowel. Okay, begins with a consonant, ends with a vowel. Has to have 2 letters. How many code words can Nell make with 3 consonants and 2 vowels? It's easiest here. Go ahead and just draw out a diagram of it, right? I don't know. How about G H T? So those are our 3 consonants, and I have 2 vowels. I don't know. U and A. Okay. Well, G, I could have GU, because it says it begins with a consonant, ends with a vowel. I could have GU, and I could have GA. H, I could have HU or HA. I could have TU or TA. So how many possible words can I make? How many possible code words? 6 code words. And number 9. Ali is building a patio. The patio will have 8 tiles in each of 13 rows. Ali built the center section with 4 tiles in each of 7 rows. How many tiles are needed to complete the patio and show your work? All right, so 13 rows. Let me use this marker, see it a little better. All right, so we have 13 rows, and in each row there are 8 tiles. 8 tiles in each row. So let's draw out our 8 tiles. All right, so there's our drawing. 13 rows of 8. Okay. And Allie built the center section with 4 tiles in each of 7 rows. Built the center section with 4 tiles in each of 7 rows. Okay, so we just need to find 7 in the middle with 4 across. 4 there, and we need to go down 7. Okay, so I'm calling this the center section. 4 by 7. The whole thing is 8 by 13. Okay, so if the whole amount is 8 times 13, right? We have to fill the whole thing in with tiles. We have to fill the whole thing with 13 rows of 8 tiles. So 13 times 8 minus what's already been used. She's already used 7 rows of 4. So she's already used 28 tiles. She needs 8 times 10 is 80. 8 times 3 is 24. She needs to use 104 tiles to complete the whole job. Okay, 13 rows of 8 would be 104. We already used 28 tiles. In our drawing, that would be this middle section. The middle section was already used, 7 times 4. So how much is going around it? And we can find that by subtracting. So 104, take away 28. Can you take 8 from 4? No. And I can't borrow from the 0 tens, so I'm going to borrow from the hundreds. I'm going to rename the hundreds as no hundreds and 10 tens. Now I can rename that to 9 tens and 10 ones. So 14 take away 8 is 6. 9 tens take away 2 tens is 7. She needs 76 tiles to complete the job. Okay. So the basic point of the lesson was to draw a diagram so you can visualize the problem. Okay. There's many ways we could solve these problems, but as far as seeing it visually, this is what I would do. And so until our next lesson, may the numbers always be in your favor.